Hey there, welcome back to another episode of our robot project here. So today we're going to be introducing our very first sensor, the button. But before we do that, I'm going to go ahead and cover the challenges from the previous episode. All right, so I'm going to pull up our whiteboard here. Okay, so this is where we ended on the last episode, where we created a circuit with two LEDs and two resistors. Now, the first challenge was to create a another circuit with three LEDs and three resistors. And we also learned this was called a parallel circuit. So we see we have two LEDs here. I'll label them here. We have LED 1 and LED 2 here, okay? And they're side by side, and the two resistors are side by side too. And so what we want to do for the third one, you just add another resistor and LED. We'll call this one L3, side by side. And the important thing here is that the resistor is connected to the same spot as all the other resistors, okay? And then same thing as we have the plus and a minus. Let me move my board over here. The plus and minuses, so the plus is here, okay, that connects to the resistor, and then the other side of the resistor connects to all the other parts of the resistor, and then the minus here connects to all the other minuses of the LED. Okay, so now you have three resistor and LED combos in parallel. That's it for three. So let's go ahead and do that. I'm going to change my view here so you can see my breadboard. And I'm going to zoom in. Okay, so we can see this as best as possible. Okay, so now we're going to do L3. So I'm going to get my bag of components here. All right. I have a third LED. And then I also have, okay, get rid of that. And then I also have a third resistor. Okay. I'm using the one with the red stripe right now. Okay. And let's go ahead and build this. All right, so let's start with where the resistor goes. So if we look at the resistor, one side of the resistor connects to 5V, and we have a 5V power rail. All right, so let's go ahead and do that. Okay, so I'm putting one side of the resistor into the 5V power rail, this red rail right there, and the other side of it is going to connect to the plus of the LED. Now the plus of the LED is the long leg of the LED. All right, so then that needs to connect to this resistor that's sticking up. So how do you connect it? Just put it in the same row. So let's do this. I'm going to bend this over, stick it up here into row 1. Okay. And then put the long leg in. And then the minus leg, I'm just going to put it, let me do this here. Okay. So the long leg to the same row as the resistor, short leg onto another row with nothing on it. And then that needs to connect to the common ground. So the minus connects to the common ground. So let's go ahead and grab, I have another brown one. Brown is good for ground. So one side of this pin-to-pin cable goes to the minus leg row. And then I have my GND or common ground rail, this blue rail here. And then I can connect it anywhere along that. There. Okay. Cool. So now if I plug it in, get my power from my USB here, I should have 3 lights, and I have 3 lights on. Sweet. Okay, easy enough. Now let's go back and do the next challenge. The next thing to do, let me zoom out here. Okay, the next thing was to create a circuit with 4 LEDs. Okay, make sure you have room to see here. Okay, 4 LEDs. Now, we don't have any more of these discrete LEDs, these green ones here, but we do have 2 of these in the kit. Okay, remember these guys that we did on the first day. Okay, so let's start with one of them. Now these, the nice thing about these is that they have the built-in resistor here, which you can see is inside this black shrink wrap stuff here. So then we don't have to add an extra resistor. So let's first modify our circuit, or a schematic rather. Let's looking at the whiteboard now. Okay, we're gonna also put it in parallel now. So we're gonna have 4 LED resistors in parallel. Let's go ahead and do that. So LED 4, I'll just call it L4. There's a plus and a minus, and then there's a resistor. Okay, now the resistor is built in, so we don't have to, we're not gonna actually have to put another resistor. Remember, it's built into this this LED. And then same connections, put it in parallel. Excuse me. Okay, and then minus to the common ground. All right, so let's see if we can do this. Ah, you know what? You know what's cool about the way we have this, right? We have this power rail. So let me change to our big view here, and let me fix our circuit so you can kind of see it in that bottom left. Okay, so this LED 4, the 4th one, we have the red, which is the positive, which has the resistor built in. Okay, that connects to 5V just like everything else, and then the black wire needs to connect to the common ground. Now we have these nice power rails, and the spacing is such that you can just do this. You just plug it in. So let me first disconnect that. Remember, just for safety, we want to disconnect before we do some wiring. And we just put the red into the red power rail, and then the black into the blue ground rail, like this. Look, it just fits perfectly. It's the same spacing, so just stick it in like that, and boom. That was pretty easy. Let's make sure it works. Yep. Now I got 4. All right, let's just finish up the challenges. Let's add the 5th one, and then we'll be done. Cool. Let's go back. Now this is getting pretty crazy. I think you could probably do it without me even showing you, but just to make sure, we got the 5th LED now connected in the same way. Look at that, 5 LEDs in parallel. Okay, let's make sure you can see this. There we go. And then we just do the connection on this. Okay, and it's going to be the same situation, right? Where we take our LED here that has a built-in resistor, and we just put it, the red in the red power wheel and the black in the blue power ground wheel, like any of these, right? That would be good. And then we turn it on. Boom. Let's do this. Turn it on. And we have 5 LEDs on. Perfect. So one note here. All right, so we have 5 LEDs here, and so what's going on? If we look at our parallel circuit here, okay, we see that all 5 of these LEDs are taking power from the 5 volt, okay, and then it's going through the LED and then back into the common ground, right? And so if I draw out, I'm going to use a different color here, okay? Let's go highlight. I'm going to use this kind of magenta, okay? So what happens is that you have power coming from the 5V, and then part of it goes into this LED. Another part of it goes into this LED. Another part of it goes into this one, and this one, okay? And it comes all the way through. And you notice that each LED creates a loop, a closed circuit, okay? If you didn't have that, these LEDs wouldn't work. So you have all these, if you look at it, you have 1, 2, 3, 4, 5. You have 5 loops, a small one here, a bigger one here, and then a bigger one here, and then so forth. So this is a parallel circuit, which we learned about. Now, question for you to think about: how many LEDs could I add for this in order for it to and have it still work? Well, one might think, well, I've added 5 and it seems like it's no problem. Could I add 6? Could I add 10? Could I add 20? Yeah, you know, there's those, you could add those, but what's actually happening is this, okay? Every time you put in an LED, it's splitting the amount of electricity, you can call it power, between those LEDs. It's like sharing. Like, let's say you're sharing a pizza, right? If you share it between 2 people, everyone gets half. Great. If you share it between 5 people, everyone gets, I don't know, 2 pieces, right? If you share it between 100 people, everyone's going to get a little sliver. Okay, same thing here, except the pizza is electricity. Okay, so what's actually happening, if you add, as you add more LEDs, the amount of electricity into each LED is getting less and less and less. So the brightness then is also going to be reducing. Now with the 5 LEDs, you might not be able to tell that it's getting less and less bright, but once you added 10, 20 LEDs, 30 LEDs, you will definitely see it start dimming because there's only so much electricity coming out of that 5-volt regulator on the Arduino Uno. And at some point, you're going to be splitting it so much that the light's not even going to be on. It's like splitting the pizza with 100 people. It's like, what's the point? We're all eating like a crumb or something, right? So same situation here. So just a little tidbit. Now, before we move on to the button, we had one more thing to talk about, which was we have 2 types of resistors here. Okay, one of them is 470 ohm, and one of them is 4,700 ohm. Okay, so the one that we've been using on here has a red stripe on it. Okay, and then we have 3 that I haven't touched yet. These do not have a red stripe. All right, and then the challenge was which one is 470, which one is 4,700. Okay, so if we think about it, and let me zoom in here so you can see our 2 numbers here. Okay, 470 and 4,700. Okay, so if you think about it, the higher resistance, which is 4,700, has more ability to block block electricity. Okay, think of it like football season starting, so I'm thinking of like offensive linemen in football. Okay, the larger the offensive lineman is going to be able to block better, right? And so nothing's going to get through to the quarterback, for those of you who kind of enjoy football. Okay, so the bigger the lineman, or the bigger the resistance, the more it can block the electricity. And what should that do? If we block more electricity, that means less electricity is getting through. That means it's going to be dimmer. Okay? If you have a smaller lineman, like the 470 ohm, everyone's going to become the quarterback. So more is getting through, more electricity is getting through, quarterback's getting sacked. And also, with more electricity, the lights are going to be brighter. Okay? So all we have to do now is say, okay, so we see this certain brightness here, and I have this one with the red stripe. What happens if I switch it out with one of these? Okay, let's see what happens. So I'm going to take one out. All right, and I'm going to take, it doesn't really matter which one you choose. I'm going to take this one out here. I'll first disconnect. Okay, just switch it out. Just going to switch it out here. So power into there, into there. All right, let's see what happens here. Plugging it back in. Okay. So I can definitely tell. Not sure if you can tell from the camera. The brightness level is kind of hard to tell. But when I put in my new resistor without the red stripe, this one is brighter than the other two. The other two have the one with the red stripe on it. Okay, so what does that mean? The new one I put in is brighter, so it means that it's a smaller resistance. So it means the new one I put in is 470 ohm. Okay, so the 470 ohm one, if we look closely at the all the colors here, 470 ohm one is yellow, purple, brown, gold. Yellow, purple, brown, gold. Okay, and then the 4700 ohm one, which is this one with the red stripe, is yellow, purple, red, gold. Okay. Now, if you look online and look up resistor color codes, there's actually a number is associated with each of these colors, and then the position of the color represents the position or the magnitude of the number. So you can look into that if you would like. I'm not going to go into that right now, but if you just look up how to read resistor codes, that'll be a kind of a good challenge too. You can look it up and then see if you can decode this yellow, purple, brown, gold into 470 and yellow, purple, red, gold into 4700. Okay. So I'm gonna leave that to you. Now let's go ahead and talk about buttons. All right. So I'm gonna change our view here, and here we go. Okay, button time. All right. I'm gonna disconnect this. So button. All right. So button. If we look into here, we have two of them. Let's go ahead and just grab one right now. It has 4 legs. Okay, I'm going to zoom in for us here. Looks like this, okay? A 4-legged spider kind of, okay? And I'm going to go ahead and draw the button. And first thing we want to do is when we draw the button, we want to make sure that the legs are side to side, like this way. Okay, make sure you can see it on the side. So not like this. This would be the legs are on top and the bottom. We want it side to side, like this. Okay, so let's go ahead and draw it, and I'll explain how this works. Okay, here's our button, 2 legs. Okay, I'm going to call this the 4 legs. I'm going to call A, B, C, and D. And I'm going to draw a line from A to B and C to D. So the button is a sensor because it's going to allow your robot to quote unquote feel, okay? Because when you press the button, your robot is going to be able to sense that being, oh, someone's pressing me, all right? Now, the thing with sensors is that in order for it to actually work, you need to create an electrical signal. You need to somehow, via electricity, tell the robot that something has happened, okay? So that's something to remember. Every time you're using a sensor, something's going to be happening electrically for the robot brain to actually know what to do, okay? So right now, I drew these lines because if we look back on I know it's kind of hard to see. I'm bringing it up closer here. Okay. A goes from side to side. And if you flip your button over here, if you turn it at the right angle, okay, you should be able to see those lines. The lines that I drew on the whiteboard there, you should be able to see it. I'm zoom in here so you can see. Okay, now those lines represent a connection. All right, so there is an electrical wire that connects A to B and a wire that connects B or C to D. So those are always connected, kind of like the breadboard. C and D are like holes on the same row. A and B are holes on the same row. But the top row and the bottom row are not connected until, so let's draw a dashed line. If you look on the little drawing there, okay? I have a dashed line until whenever you press the button, when you press the button, all the legs are connected, okay? So when you press the button, now every single leg is connected, and then if you connect that into a circuit, you can make something happen electrically. Okay? All right, so now let's see, we can do something with this. Let's use our button, okay? Okay. Let's create a circuit where when we press the button, it turns on. Okay, here's what we're gonna do. We have our Uno here. We're gonna have a 5-volt source, okay, power. We're gonna have a resistor. We're gonna have an LED. And then we're also gonna have a button. So how do we do this? Well, let's connect the minus of the LED to the top leg here, and then this side, G and D, to the bottom leg here. And let's draw the wires here to remind us what's going on, okay? So what we have here, we have a circuit but with the button built in. All right, so if we don't press the button, what happens? If we don't press the button, electricity will try to do this. It'll start from here, go through the LED, it'll try to, but then here, it wants to get to the G and D, but it can't because the top is not touching the bottom when we don't press the button. You see that? So it's going to be an open circuit because it's not closed and there's not going to be electrical flow, so the light's going to be off. But when we press the button, what happens? When we press the button, draw by dashed line here. When we press the button, the top connects to the bottom, all legs are connected. And then it's like this, go through the light, and it's like, whoa, cool, I can cross the bridge, come down, go all the way through, my light turns on. Okay, so let's go ahead and build this and see if we can make sure it works. Okay, here. All right, so we have our circuit here. Okay, don't freak out, I'm gonna take everything off, okay? We're gonna be building and rebuilding this. The thing about the breadboard is that it allows us to make connections really quickly and then also take things off. So it's great for prototyping is the word. We're trying to create something rather quickly to see if it works. So it's natural that you're going to be taking things on and off. Okay, and as we get better at it too, you're not going to be nervous about like, oh, I didn't made all this work, you know, because this is going to be second nature to you. All right, so everything's off. Let's go ahead and build this circuit. Let's go. I like to use the power rail, so let's do that power rail with the red wire first. So I got 5V to the Uno, 5V, okay, that's in the 5V, and then let's put that into the power rail. I'll use the top here, stay organized. Okay, and then let's just, let's take care of the ground rail. Well, you know what? Let's do it. Let's do it the way that I typically like to do in the beginning, which is we start with the 5V and then go to the resistor. Okay, let's get a resistor. And now that we know the resistors, let's use a 4,700 ohm, which is the one with the red stripe. And let's do one side onto the power rail and the other side into a new row somewhere. Okay, and I'm going to try to do this neatly. Okay. All right. And then let's put in our LED. So I'm going on the other side of the resistor goes to the LED. So I'm going to take one of these LEDs here. The long leg goes into the same row that I just made with that resistor, and then the short leg into the row underneath, a blank row with nothing in it. Okay. Again, I'm trying to make it cleaner this time. That always helps. And then what happens? The short leg needs to connect to the short leg of the LED needs to connect to the top row of the button. So let's get our button here. Okay. Now I want you to notice the button here. See the legs? They're kind of curved. Okay. So that helps it grab onto the breadboard. But what's tricky, because it's kind of like a claw, like this. What's tricky is that if you try to put it straight in, it's possible that these legs won't go straight in. I get kind of caught, and then you'll just crush the leg, and it'll break. Okay. So what you got to do is you got to kind of wiggle it in. So you go like this, like rock it side to side, and then it'll go in. Okay. Don't just like boom, try to jam it in. So this is the top. It doesn't matter which is the top, you know, it could be this way is the top or this way. These legs are the top. As long as you have it side to side where the legs are on the side, okay, you're fine. Now, so my top is up here, okay, where my finger's tapping right now. That's my top row of my button. That needs to connect to the bottom leg of the LED. So I'm going to do one of these like this. Okay, I'm going to do a wiggle. Okay, and now just so you know, the appropriate distance for these two legs here, the top on the top row here, should be 4 holes. That should help. So you see that? It's spanning 4 holes. If you try to do 3 holes, it's gonna break. Okay, cool. So I got it in there. Okay, so it looks like this. If you're not sure, you could just do exactly like me. All right. So at this point, I've used up the entire row 2 here. All right. Okay, cool. So that's in there. Now the next thing I want to do is the bottom leg of the button goes to GND. Cool. So I'm going to use a black wire here, pin to pin. Okay, I have one side to here. Okay, and then the other side to let's put it into the ground rail. Okay, so that's a ground rail, but I also need to connect my ground rail to GND. So let's use another black wire here. Okay. Another thing, you notice that this is not really going in. So the thing about these, once it's straight, your pins are straight, it should go in pretty easily. So, you don't want to be too rough with it. So this is slightly bent. That's why it's not. So these are just kind of like little tips so you don't break these little wires. So I'm going to use the other side. Try that. Let's get it in there. And for some reason, you know what? There's a little like solder. You know what? I'm gonna grab a different wire. I don't want to break it into there, so I'm gonna use this brown one. This looks a little cleaner. Okay. Yeah. Interesting. Sometimes it just doesn't want to. Oh, there we go. Okay. So it's good that you saw that for me. So if you can't get it in there, you can try to wiggle it a little bit. Don't force it, because then you're gonna break the pin. All right, this needs to go into G and D. Okay, and let's see if this thing works. Okay, plugging in. Okay, so the light's not on because I didn't press the button yet, right? It's an open circuit. When I press it, it should be close the circuit, which will allow the electricity to jump from the top row of the button to the bottom. Boom. And it works. Excellent. All right, let's keep going on this a little bit. Every time we learn about a new component, we just want to add a little bit more complexity to practice, right? Okay, so what if we want it where when we have two lights that turn on whenever we press the button? Let's see. Okay. Well, we just do it in parallel. Okay. So same situation as before, where we connect a resistor and an LED the same way, next to each other in parallel. So we're going to go here, put another one of these resistors, another LED, and then this will connect to here. So not G and D, because if I connect it to G and D, this would always be on. Okay, but we're going to connect it to here so that when we press the button, both this LED here and this LED here will turn on, because they'll both have closed circuit paths from 5V to G and D. All right, let's try it out. Okay, I'm going to disconnect. Okay, so now we have two LEDs, two resistors. All right, let's go with a 4,700 ohm again. First thing is power rail to this resistor. That works. I'm just going to put it here. All right, now the next thing is that needs to connect to the plus leg of an LED. Let's see if we can just put that there for now. I'm really not sure how it's going to turn out, but we'll see. We might need to change something. So the plus leg of the LED needs to go into this row, same row as that resistor, and the minus leg is going to go into a new row. Okay. And then what happens? Then the minus leg of the LED needs to go to the top row of the button. Okay, top row of the button is right. If you see, I'm trying to use my little resistor leg to show you. The top leg of the button is right here, but I don't have any holes left on the top legs of the button, so that's not going to work, right? So let's go. I'm going to take this off so we don't get confused. So I need to have more holes on the top leg of the button. So what I can do is this. All right, I'm going to take off my G&D connection. And take this off. Take the button off. All right. So I'm going to make the same circuit. I'm going to move my LED over a little bit. Okay. But now the top legs of the button, I'm going to make it cross over the valley. Like that. Okay. And again, I want to wiggle it instead of forcing it in there. Wiggle it so that it grabs on. Cool. Okay. So what does that do? Now that I put it across the valley, I've now connected, the top legs have connected all these holes and all the holes here on the other side. Okay, and so now I have all these holes for the top and all these holes for the bottom. Let me use my pen here. So all these holes are connected to all these holes, and all these holes are connected to all these holes. Okay, now let's connect back our GND for the first circuit, which would be the bottom row of the button. Okay, I want to make sure that that still works. Okay, that still works. That's good. Okay, now let's add that second LED. All right, get our resistor. Okay, one side into the power rail, other side into a new row. Like that. Now let's get our second LED. Okay, long leg is connected to the resistor. And then short leg needs to connect to the top leg of the button. Like that. So how am I going to do that? The short leg is right here. I'm going to connect orange wire into the short leg row of my second LED. Okay, and then that is going to connect to the top leg row of the button. I'll just go over here, you can see it better. The top row leg is right here, so any of these holes. There. Okay, let's see if this works. Press, and 2 LEDs. Awesome. Okay, so I'm gonna leave it there for now, and let's talk about some challenges to work on. Okay, so I now have a button with 2 LEDs. The next step would be, let's do a button where we, let me write this down here. Let's do a circuit where sorry, we got to make sure you can see what I'm writing here. Okay. Let's do a circuit where we have one button turns on 3 LEDs. Okay? So you press the button and it turns on 3 LEDs. And then another one where it's one button turns on 4 LEDs. So similar to what we did earlier. Fix this. Okay, and then I'll do a little tricky one. One button where we have one LED on always, and one LED on when you press. Okay, so that last one, this one right here, it's kind of tricky. So the way that it will work is that the LED, one of the LEDs is always on no matter what. So whether you press the button or you don't press the button, it's just always on. Okay, but then the other button, but the other LED, it only turns on when you press. Okay, so that one's a little bit more tricky, but wanted to add a little bit of a twist for you there. I'll leave it there for now. The next video we're gonna do a little bit more on buttons, and then after that we're gonna be learning about switches, and then once we learn about switches, we're gonna start coding, which was the really cool part, which is when your robot or your lights are able to turn off and on its own, because it's going to be doing it through the brain of the computer rather than you pressing stuff or switching stuff on and off. But first, let's try these challenges. If you have any questions, always reach out. And thank you for following. I will talk to you later.